Hello everyone and welcome back to the series on Ultimate CBSE Maths exam, and in this presentation I am going to talk about some of the most important questions on the topic of matrices. So here's the first question that I have already written. So let's say we have a matrix A, which is a n squared matrix, and we need to prove that A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. So based on what we know and what is in our toolkit, how will you approach this problem? How will you tackle this problem? So let us think about it. So we know that A plus B whole transpose is simply equal to A transpose plus B transpose. So this is one of the properties that I showed you in the previous video. So let us use this and arrive at this conclusion. So let us say that A plus A transpose, this is actually A transpose, so A plus A transpose whole transpose is equal to, now let us calculate the right hand side using this above formula. So this is going to be A transpose plus A. So I just showed you that when you take the whole transpose of left hand side, what we get on the right hand side is same as this. So we just proved that A plus A transpose is a symmetric matrix, because you see this and this are both equal to each other. So, and we know that if a given matrix and its transpose are equal, then that matrix is called a symmetric matrix. So A plus A transpose is a symmetric matrix. Now let us prove the second subpart. So I'll change my color to white. For the second part, we will apply this property again, and let's say that I take my B as minus of A transpose, and then I take the whole transpose of this. So what I'll get on right hand side is A transpose minus A. Now in order to prove that it is a skew symmetric matrix, we can take -1 common, and then we are left with A minus A transpose. So let us observe this. This was our starting matrix, and this is the final matrix. So you can clearly observe that these two are the same, except we have a -1 sign. So this satisfies the property of skew symmetric matrix. So basically what we just proved in first question is, given a matrix A, which is a n squared matrix, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. Now I want to talk about another question. So let me go to this layer, and so here's my second question. We change the color to white. So in this question we are asked if A is a skew symmetric matrix. So A is a skew symmetric matrix, then we have to determine the determinant of A. So how will you tackle this problem? So let's start with the basics. So we know that if a given matrix A is a skew symmetric matrix, then we have the following condition: A, I, J is equal to minus a ji. This is a condition for skew symmetric matrix, you might recall. So now let us say that this is our 3 cross 3 matrix. So this is a square matrix, 3 cross 3, and we need to determine the determinant of this matrix, which I am calling A. Now if you will observe that if aij is equal to minus aji, what that means is the elements of the principal diagonal are equal to 0. Now why is that the case? Well, because if you take this to this side, and if you remember in principal diagonal all the indices of the elements are the same. What do I mean by that? Now I is equal to j and j is equal to I for all the elements in the principal diagonal, which is the left diagonal. So we have a I is equal to minus aii. Now just bring this term to the left hand side. We have 2 aii is equal to 0, which means aii is equal to 0, which means that all the elements on the principal diagonal are 0. So this is 0. So let us consider all the other elements. Now if you think about it, since we have to satisfy this condition, we can take this element as f and we can take this element as minus f, because this is the element of third row and second column, and this is the element of second row and third column. So this satisfies this condition. Similarly, we can take this as g, and this is minus g, this is h, this is minus h. So this is the matrix A. Now if you take the determinant of A, it will be equal to 0, and you can obviously prove this. You can do the computations. It will come out as 0. So basically what we can conclude by this question is that if we have a skew symmetric matrix, the determinant of odd order is 0. So in this case the order was 3 cross 3. So 3 is an odd number. So whenever we have a skew symmetric matrix of an odd order, the determinant of that matrix is going to be 0 in every case. So that's the second question. Now I want to talk about the third question. So this is a very important and fundamental question. So let's say that this is my matrix A. Let me construct the matrix. 1 2 4 6 8 1 3 5 7, and I want to determine the symmetric and skew symmetric parts of the matrix A. So I want to express A as symmetric and skew symmetric matrix. So how will we tackle this question? So let's think about all the tools we have in our toolkit. So we know that A plus A transpose is a symmetric matrix. We also know that, so this is a symmetric matrix. We also know that A minus A transpose is a skew symmetric matrix. We just proved that. Skew symmetric. Now if I want to represent A as a sum or anything of skew symmetric and symmetric matrix, I can just do a simple algebraic manipulation here. So let's say that this can be written like this. So if you think about it, I didn't do anything fancy. All I did was some algebraic manipulation, and if you look at the numerator, it's going to be equal to a plus a divided by 2, which is just 2a divided by 2, which is just equal to a, and a transpose minus a transpose divided by 2, which is equal to 0. So basically this is a way of representing a, and we can always do that, because if you add something to an expression and if you subtract the same thing from that expression, it's going to leave the value of the expression unchanged. So after you did that, basically it's pretty straightforward. We just take the a transpose. So the transpose of the given matrix A will be, so this is pretty simple. We just interchange the rows and the columns. So the first row 1 to 4 will become my first column. The second row 6, 8 and 1 will become my second column, and then finally my third row 3, 5 and 7 will become my third column. So this is the A transpose. Now all you have to do is plug this value of A transpose in this equation, and then just simply perform the addition operation and the subtraction operation, and you can express the given matrix S, this is actually A, given matrix A, as a sum of symmetric and skew symmetric matrix. So thanks for watching this video. If you have any comments and if you are struggling with any problem, you can always message me and I'll get back to you.